Hello, so today we are going to solve this shortest distance to character. So we have a string S and the character C, and we want to return an array of integers representing the shortest distance from C in the string to from C to that letter. So for example, L and C is E, so we have only 3. So you kind of count the letters including the last one. And then for O, it's 2 letters, V like this. And then for V, it's 1, and then for E itself, it's 0. So you get the idea. So the simplest way would be just when you encounter the letter, just check to the left and to the right, and see the closest one. So what do we want to return here? So what we want is list of min distances from letter from each character in S to C. Of course, C in S, right? And so and the data we have here is just the string itself. And so we have 2 directions, right? We have this and then this direction. So what could help us determine this solution faster? So here in the example, C is E. So when we are here, let's say at V, can look left, find the min, look right. As soon as we encounter it, we stop, and then look right, and as soon as we encounter it, we stop, and then take the min between the two, right? So let's try that. So we need to enumerate S here, and then from there go to the left. So check on the left, and then check on the right side, right? And so checking on the right side would be while maybe let's have k here equal to I, and then while k bigger than 0 or equal to 0, we'll need to do like this, and then just if s of k is equal to C, then we are done, right? So break. At that point, we will have K is the position of where we found C. So that's the distance we want, right? No, that's not the distance actually, because so I'll say left basically, and I'll just keep increasing it. And then on the right, we'll again do this is +1. Okay, so if we include the current position like we are doing here, so basically, let's say from here we include this one. Let's say from D here, or from C. If we are going back, we'll include C and then T, and so naturally it should be 2. And so when we reach E, we should break, and so we need to put the increment here. And then For this one, we could leave it as that and then just say while k less than the length of s, right? And then do the same thing here. If we find c, we break and then do right. Here we'd have right, and then we'd have 0 here, and then we need to increment right, and we need to increment the index, and then here we need to return min, not the return, sorry, this is adding it to the list of left and right. And then we are going to say res like this, and then say res append and then at the end, so we already checked the right, we could just return res. Tuple. So yeah, so enumerating here should be maybe, let's say that. That way we could just say character here, and yeah, no, we need sk because this is si. It's capital C. So it seems like it's correct for all of them except to the first one. So for some reason the first one, yeah, the first one shows kind of the, so the first one is L, right? So it should have been 3. But if you are like at position 0 and break, then yep, we shouldn't, so we should start, so the min here would take 1, right? Because we will start from L 0, so that will be 0, and then go to just do my 1 minus 1, but we would have incremented left, right? So that won't work, right? Basically, if you go left and never find C, then we should not take that value, right? So maybe we should have instead res, which starts out as float, infinity. So let's say here this is best, right? Or min distance, right? And this, let's initialize it for every one of them here. And only when you find it, that will say min distance is equal to min of whatever was in min distance and left. Right, and then we break. Otherwise, it won't have anything, and so the same thing happens here, which would be this or right. And then we break, and then right would be correct here, and then this here can just be min distance. Okay, so that looks good. Let's try with a couple of other test cases, maybe Leetcode, say C, code, maybe O. We can have also one letter, so let's say C, and maybe give C as well, or let's say C and maybe give B. Sounds good. Okay, so that passes. Cool. Okay, so let's see if we can simplify this solution. So what we are essentially doing is trying the left and trying this right and seeing which one gives us the best distance, and then adding that one to the list. So here we don't need actually to do the while loop, right? So we could just do initialize this to 0, so that will be left here, initialize to 0. And we could just do for maybe k in range of, so the range we are looking for we are looking for here is starting from I, so, and then going to -1 so that we can reach 0, and then going by -1 every time, and no need to do k -1 at that point. And then here what we are trying to do is a for loop, and so for k in range of starting from I again, and then we want to end at the length of s, and we still need right equal to 0, and then we don't need this increment here. Okay, so that still passes. Now now can we do something even better, like this left here? Do we really need it? So what is essentially doing this left here is just doing I minus k, maybe +1, maybe not. I think I minus k should be enough. That's what left is doing. So we just remove left. We don't need. Let's just test this quickly. Yep, so that still works. And then we need to do the same thing here, so we don't need right. And this should be just instead the reverse kind of, so k minus I. Okay, so that still seems to work. Let's submit. Yep, cool. So we just take the distance ourselves instead of using a counter there. Another approach could have been doing a while loop and doing while sk is different than c. Then when we exit, maybe do this. But that may not work in all cases, because maybe we exited because of the because of k here. Okay, so, but this looks reasonable. Actually, a better way we can do this is, instead of doing this min distance here, just initialize the array with infinity. So this would be in range of length of s. And from there, what we'll do is, so we'll take res of that element, that position, and that will be just res of I. We no longer need this. And same thing for this one, and here as well. And that, no need to append anymore either. And that's pretty much it. And we can try to submit this. Okay, cool. So that passes still. Let's see. Yeah, so this is a lot better. and a lot more readable. So another optimization that we can identify here is that since the character is guaranteed to be in the string, the max possible distance would be n. So instead of using float here, we can just use n, the length, right? That's the max we could have. So just say length of s and use that here. And then here, instead of doing, we don't need to actually do, since we are using sk, we don't need to enumerate, so we can just go through the range of n, right? So that still passes. But also for this here, we don't actually need, we can do it in this, like the body here is exactly the same, except of course I minus k and k minus I here. So what I'm thinking actually, that if we do use just one loop and just maybe go the reverse here, so just do the reverse here, no longer need to do this. And here we probably just need, this is not k, it's I. Whenever we encountered it, we will need to put the position that we encountered it at here. Well, let's call it k, and maybe here just take the absolute value, because in case it's negative. And that should be it. Let's try list. So k reference before assignment here, let's just initialize it to maybe I. No, not I, because that would have been 0. I think maybe the length, the maximum possible. No. So actually what we need from position is just for it to be the smallest possible value. So let's just initialize k here to, or let's just call it maybe, yeah, k, position or something like that. So position, and this would be float of minus infinity, and then we could use that position here, and then use it here as well. Yep, that should cover it. Okay, cool. Okay, so that it's using one list works as well. Cool. Yeah, so that's it for this problem. I'll see you on the next one.